When does the horizontal range when does the horizontal range of a projectile thrown from ground thrown from the ground become maximum? When does the horizontal range of a projectile thrown from the ground become maximum? In the diagram, this is a projectile of mass m which is thrown obliquely with the ground in this way from the point O. The projectile describes parabolic trajectory and strikes the ground again at the point B. Projectile strikes the ground at the point B, and this projectile is thrown with the initial velocity u at an angle theta with the ground. And if this initial velocity and the projectile strikes the ground at the point B with the velocity v, at t equals 0 the projectile was thrown, and at the time of instant t equal t1 plus t2, which is equal capital T, and r is the horizontal range or horizontal displacement of the projectile. Now we can resolve the initial velocity u. Ux is the horizontal component of initial velocity along horizontal direction. Uy is the vertical component of initial velocity, which is equal to u sine theta. And vertical direction, y-axis is the vertical direction. The horizontal range of the projectile, the horizontal range of a projectile is given by r equal u square sine 2 theta divided by g. R equal u square sine 2 theta divided by g, which is equation 1. R is the horizontal range. If theta equal 45 degree, sine 2 theta is equal sine 2 into 45 degree under bracket. Therefore, sine 2 theta is equal sine 90 degree. Therefore, sine 2 theta is equal plus 1, which is maximum. Sine 2 theta will be plus 1 when angle of projection theta is equal to 45 degree. If the projectile is thrown at an angle 45 degree with the ground or with the horizontal, in that case sine 2 theta will be maximum or 1. That means if theta equal 45 degree, then horizontal range will be maximum, which is denoted by R max, equal u square sine 2 theta divided by g, equal u square into 1 divided by g. Therefore, R max is equal to u square divided by g. R max is equal u square divided by g, which is the maximum horizontal range of the projectile thrown from the ground at an angle 45 degree with the horizontal. R max is equal to u square divided by g, which is the maximum horizontal range of a projectile thrown from the ground. When a projectile is thrown at an angle 45 degree with the ground, when a projectile is thrown at an angle 45 degree with the ground, the horizontal range of the projectile thrown from the ground, the horizontal range under bracket capital R will be maximum. Now we can consider that the projectile will be thrown at an angle 45 degree and 75 degree, and in which case horizontal range will be greater or maximum. A projectile is thrown and it will describe this type of parabolic trajectory or path and strikes the ground at the point B, and the projectile is thrown at an angle 45 degree. In that case, horizontal range of the projectile will be maximum. That is, horizontal R max is the maximum horizontal range of the projectile which is thrown at an angle 45 degree. Again, if the same projectile is thrown at an angle 75 degree, in that case the projectile will describe this type of parabolic trajectory again and strikes the ground at the point B prime. Obviously at B and at B prime the projectile will strike the ground when they are projected at an angle 45 degree and 75-degree respectively. And for 75-degree, the horizontal range will be R1. Now 45-degree less than 75-degree, but R max will be greater than R1. R max is the horizontal range at 45-degree, and R1 is the horizontal range at 75-degree. When the projectile is thrown, when the projectile is thrown at an angle of 45-degree with the ground, then horizontal range R will be denoted by R max. R max is equal to u square sine 2 theta divided by g, equal u square sine 2 into 45-degree divided by g, equal u square sine 90-degree divided by g. Therefore R max is equal u square divided by g. R max is equal u square divided by g, which is the maximum horizontal range for a projectile thrown at an angle 45-degree with the ground. But if the projectile, but if the projectile is thrown at an angle of 75-degree with the horizontal, at an angle of 75-degree with the ground or horizontal range of the projectile will be R1, which is equal to u square sine 2 theta divided by g, equal u square sine under bracket 2 into 75-degree bracket close divided by g. U square sine under bracket 2 into 75-degree divided by g, equal u square sine 150-degree divided by g. Therefore R1 will be equal u square divided by 2g. R1 will be equal to u square divided by 2g, which is the horizontal range of the projectile when the projectile is thrown at an angle of 75-degree with the ground. Here sine 150-degree is half. Therefore we can say that R1 is greater than R max. R1 is greater than R max. At theta equal 45-degree, R max is equal to u square by g, but at theta equal 75-degree, horizontal range R1 will be equal u square divided by 2g. U square divided by 2g. That means 45-degree, though 45-degree is less than 75-degree, but the horizontal range at 45-degree is R max, which will be greater than the horizontal range R1 at 75-degree. At 75-degree, at 45-degree, horizontal range is R max, which is greater than the horizontal range R1 at 75-degree. Therefore we can say that R max is greater than R1. Again, we can consider the horizontal direction or ground. This is ground. This direction, a projectile will be thrown from the point O, and the projectile has the mass m. If the projectile is thrown at an angle 45-degree, it will describe this type of parabolic path and strikes the ground at the point B. Along this direction, the projectile will strike the ground, and the projectile will be thrown at an angle 45-degree, and horizontal range of the projectile will be R max, and that will be the maximum horizontal range. If the projectile is thrown at an angle 45-degree, horizontal range will be R max, which is the maximum horizontal range. If the same projectile, if the same projectile is thrown at an angle 75-degree, in that case the projectile will strike the ground again at the point B prime along that direction, and this projectile is thrown at an angle 75-degree with the ground from the point O, and horizontal range R1 will be equal to R max by 2, and here O to B prime is the horizontal range of the projectile. That is, R1 is the horizontal range of the projectile when it is thrown from the ground at an angle 75 degree. Now, if the projectile is thrown at an angle 15 degree, if the projectile is thrown at an angle 15 degree, it will describe parabolic path and strikes the ground at the point B double prime or B double dash. And in this case, horizontal range of the projectile will be R2. R2 is the distance of the point B prime from the initial point O. R2 is the horizontal range when it is thrown at an angle 15 degree. Now, 15 degree is less than 45 degree, but R2 is less than R max. Again, 75 degree is greater than 45 degree, but R1 is less than R max. That means R max will be the maximum horizontal range when it is thrown at an angle 45 degree with the ground. That means R max is the maximum horizontal range at theta equal 45 degree.